So I hope your other friends also will be joining. Any idea?
They will join, sir.
Okay. So in the meantime, if you have any question, any doubt, okay, apart from cam designing, because I have already said no today, basically we have completed that particular cam module yesterday. So that's a kind of doubt solving kind of session where mostly I've seen that you might have some problem with respect to designing of the cam because you have not, uh, it seems like you have not properly drawn it, okay, alongside me, even though I have been repeatedly telling. So, so that's why this specifically, if you have any doubt with respect to cam profile, that also I'll be taking. Okay. Prior to that, before your other friends join, if you have any other doubt, maybe from the first module, maybe from this module, you can ask. Anything? Rehan, Shankar, Fermiki, Teza, questions or doubts? You ask and clarify those things. Okay. Otherwise, at the end, it will be difficult, no? Okay. If you
Okay, sir.
like, it will be better if you keep on clearing your doubts together. No doubt. So everything is okay.
Yes.
Okay, then I'll consider it like yes. Okay, so what we have discussed yesterday, basically yesterday, one particular type we have seen. Okay, so in yesterday's case, we have considered flat face mushroom follower. Okay, and just like previous cases, leaf, then the different angles, ascent angle, dual angle, descent stroke angle, next dual, etc. Those things were given. Minimum radius of cam was given. You're also like the RPM is given, etc. Okay, and it was said that like raising was for which cycloidal motion. So we have to after like the two basic stages are what? First step is drawing the displacement diagram properly, considering proper scale, proper motion profile, etc. And the second step is considering kinematic inversion. You have to draw the cam profile for that particular type of cam. Okay, cam and follow arrangement. It might be offset type or it might be inline type. Okay, depending on the question, whatever is being said, that way you try to draw. If nothing is being said about offset, then automatically you consider like radial or inline type of cam and follower arrangement. Okay, so after that, the interesting point was like you should see like what type of follower they're talking about, whether it's a kind of knife edge follower or it's a kind of a roller follower or mushroom type of follower. So that way we have to consider the minimum radius of that particular cam. Okay, that circle while drawing the circle in the second stage. Okay, for drawing the cam profile, we have to consider like that. So those things I believe all of you recall. Okay, and in case of your roller follower, it was like the minimum radius plus the roller radius that they have to add it, because the trace point in case of roller follower remains at the particular center of the roller itself. Okay, so that much addition has to be there extra, that r, that is the roller radius. Okay, and also in this last problem, it was interesting in the sense that previously we have been saying that like most of the cases, like if you are saying about uniform acceleration, uniform retardation scheme, so in those cases we have considered automatically like 50% of that particular stroke, be it your whether it's a rise stroke or return stroke, it doesn't matter, but as per the question whatever is given. But we have considered like it's as if 50% of the stroke was with uniform acceleration and other 50% of that particular stroke itself is with uniform retardation. That way we have considered whenever in some question it was mentioned that that particular stroke is with uniform acceleration and retardation. But in the previous last question, it was like it was said that it was somewhat different. It was said the uniform acceleration was two-thirds of the uniform deceleration. Okay, so that means within that particular stroke itself, that is the lowering of with uniform acceleration retardation means lowering means return stroke. Okay, the follower is lowering means follower, it is the return stroke that we are talking about. Okay, so it was said that uniform acceleration was two-thirds of the uniform deceleration. So from that actually, because that was given, so from there we have found out the time of acceleration, time of deceleration for the return stroke. Okay, and from there we could obtain like what will be the displacement, corresponding displacement during the acceleration portion and during the deceleration case within that particular thing. So from there we have seen that basically the distance travel during deceleration period is two-thirds of the distance travel during acceleration. Okay, and that's why if you recall in the first step we have drawn the displacement diagram. So just like the any displacement diagram, we have considered proper scale. Then along the axis which we have considered the cam angular displacement theta, or in terms of t also we can say, because that is going to take a certain particular time. Okay, with a uniform velocity, if the cam is rotating, then to traverse a certain angular displacement it takes a certain time. Okay, those are interlinked. Okay, so in the x-axis I can either take theta or t. Okay, along the y-axis that is the lift that we are talking about, or the cam follower displacement. Okay, so this now as per just like previous cases, so what we do, we in the x-axis as per the scale we uh, take out that particular all those theta a, that is the ascent stroke angle. Then the as per the question, that is the first del means that dual we are talking about, then the descent stroke angle etc that we have talking about. Okay, and this particular portion was with cycloidal motion. So that's why as already we have discussed how to draw the displacement diagram for cycloidal profile, that we only have drawn. Okay, here we have considered 8 division, and this part is done. For dual we don't have to do anything here itself. At the end of the first stroke, it was the position of the or this mass lift was there, so here itself the follower will remain. And after that, here it is the important thing. Okay, so here theta d during the return stroke, actually the relationship was distance travel during deceleration period is two-thirds of the distance travel during acceleration. Okay, that's why if you see, okay, here this particular particle division where we are making the equal space division as per whatever number of division we have made here. So here you will see basically it's something like this much is not 50 in 50-50 ratio, but just like three. If we consider the whole portion is like divided into five equal parts, three portion, okay, three-fifth is the total time of acceleration. Okay, and that is the displacement, and two-fifth of that particular portion, parts are with retardation, uniform retardation. Okay, and after the trace is somewhat similar only. Okay, we have made that particular. Here we have made 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 division. So in here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 division we have made. Okay, and after that, from this side, this is uniform acceleration case. Okay, because right now the follower is here. From here only it is okay, and after that considering this particular person. Okay, this much. Okay, this particular line only now we are considering. Okay, and we are making that particular from this side we are dividing those division. Okay, here we'll be having 6 division, here we'll be having 4 division, just like here we have got 6 division here. Okay, got 4 divisions here. Okay, same case here, 6, here it is 4. Okay, this is how displacement diagram is drawn if the stroke is not 50-50 like that. Okay, so after that, considering your roller that's minimum radius, we have drawn that particular circle. Okay, then considering the vertical position of that particular initial position as the uh, whatever is this particular follower that we have. Okay, mushroom type of follower, flat base mushroom follower. So after that, what we have done, those different angles we have divided here. Okay, first ascent stroke angle, then the dual. Okay, then we have the descent stroke angle, then automatically this force angle becomes the next dual. Okay, and after that whatever is the number of division we have made here in the displacement diagram for ascent stroke as well as for the descent stroke, that many equal divisions we are making in the ascent stroke here, ascent angle here, and descent angle here. Okay, so here we are making like 8 divisions equally spaced. Okay, this 120 degree will divide by 8, and whatever is the angle that we will consider. Okay, similarly for the dual we don't have to do anything. And once again for the descent stroke, okay, we have considered 10 division here, so here also we'll be making 10 division. Okay, and corresponding nomenclature we have to use, like here the divisions numbers are given like 1 2 3 4 like that. Okay, so here also corresponding division has to be given the same nomenclature. Okay, up to this much it's okay. Is that okay?
Yes.
Yes.
Okay.
Yes, sir.
Okay, so after that we'll once again go back to that particular displacement diagram, and this displacement in the ascent stroke as well as in the descent stroke will be measuring with like this 1 dash 2 2 dash 3 3 dash 4 4 dash. These distances will be measuring with scale, and that much we have to extend from this particular corresponding division. Suppose from 1 along this particular line itself, 1 dash, that much amount we are going to extend up to 1 dash. Okay, similarly from 2 up to 2 dash, that much extension. Okay, similar is the case up to your 8 division, that is here the ascent stroke is done. Okay, after that there is like the dual. Okay, well, dual you can measure, or ultimately it is the same. Okay, directly that same amount itself you can extend. Okay, because there is no movement from the starting to the end of the duel. That means here whatever is the displacement, whatever is the position of that your follower at the end of the duel period also, that is the same. Okay, and similarly after from the descent stroke also you will be measuring all those 9 days, 10 days, those division distances. Okay, and along this particular line you have to extend. Okay, so that is the, and after that from those 1 days, 2 days, 3 days, all those position, what we need to do, we have to draw the end position of that particular flat face follower. And while we have to be careful in that particular case, we have to draw the flat face follower perpendicular to this particular, okay, this extension line. Okay, like this 3 days. Okay, if we show, okay, we are going to show the lower portion. Okay, like that. And similar is the case up to this much. Okay, and at the end, starting from O, this particular position, will be we'll be drawing the curve tangential to the flat faces of the follower, and that represents the cam follower. Okay, it has to be tangential to the flat faces of that particular follower. Okay, and it's a kind of freehand curve, smooth curve. Okay, at up to this much, this is the ascent stroke. From here it is the constant radius curve during the duel. Once again this is the descent stroke. Okay, don't mind my drawing. And at descent once again darken this, which shows that particular next to it. Okay, and this is the required, this profile is required cam profile. Okay, understood. And after that, depending on whatever is being asked, okay, using the known relationship you can just find out all those phi max, okay, maximum velocity, maximum acceleration, etc. for ascent stroke as well as descent stroke. But you have to be careful, whatever is the type of stroke, that is whatever movement was, type of movement was there, that corresponding expression only you need to use. Okay, so with this basically we have completed this particular module. This is the end of this particular module. You try some cam profile construction. Okay, and profile construction you try it. Okay, and for your assignment already I have said something. Okay, so those whatever previously told, okay, those along with, like, you try to solve the questions, okay, numerical as well as your cam profile construction problem from your CT1 problem. Okay, so those will be the first assignment. Understood? Okay, so if you have any question you ask, otherwise will be ending here because no question is, you are not asking any question. Okay, and I have
The
completed.
assignment date, sir.
Hmm?
The assignment submission date.
Submission date 15th.
Sir, first class test, that was questions, sir.
Yeah, whatever previously I have told na during those classes, those questions as well as like all those dictative etc. And from this city one.
Okay,
Okay, all those problems and climb profile construction.
and the previously discussed problems, no, sir?
Hmm?
Previously discussed problems that are also.
Yeah, those has to be completed properly. Okay.
Yes, yes,
Similarly, these three, whatever, and see, previously whatever we have told, na, I have asked you to write an assignment. Those questions. Okay. First, next is your this CT one. Okay, that theory is not required. Problems and chem profile construction, all those problems, other problems and chem profile construction. And third, okay, so you'll be submitting this like in your normal copy you have said now. Okay, you have been drawing it regularly with a proper scale and all. Okay, that also you will submit.
you cannot do in a A4 paper, sir, and make a single PDF and submit.
Yeah, single PDF only.
Okay.
Pair copy means like this solve questions. Okay, you people are writing. Some of you are doing, some of you are not doing. Okay, with proper taking proper scale and all. These three or four, whatever I have discussed now here itself. Okay, these only, but in a proper way.
Uh,
Okay,
Understood?
sir.
Sir, so you should submit the PDF of our copy also, sir. What can profile?
Yeah, copy means
Okay, sir.
you can do one thing. Okay, if you have not maintained a proper copy, then these questions, okay, you solve properly in a proper manner, not like in a rough manner. Okay,
Okay, sir.
these are already done. Okay, we have also discussed this PDF also I have provided, but this camp profile construction, my intention is if you don't try, actually at the end during exam you will get confused. And these are graphical methods, na? Okay,
Okay, sir.
so if you just
Okay,
see and like I'll be able to do or like that way if you think, okay, then you get confused. So this solve question also try and submit because I have seen that if I don't say you have to submit, then you people are not doing it. So to be like sure that you are doing, just submit that copy. Okay. So these three parts. So today is ninth. Okay. I'm giving you like when you will be able to submit this part assignment.
By next Monday, sir. No problem,
sir,
sir.
in a week, sir.
In a week,
Okay.
sir.
Okay.
By next
1 week I am giving. Okay.
Monday, sir.
Okay.
Okay, sir.
Okay. Then okay. So if you have any question, you can ask. Otherwise, we'll stop here.
Sir, the assignment is only regarding cam profile, sir. Others topic not required, sir.
I
Sir.
have already discussed. Na? You
Oh,
go through this video if I when I upload it.
okay, sir.
Because each and every time same thing if I keep on repeating it's of no use. Okay, respond to your name calls. Nirupal,
Present, sir.
Shankar,
Present, sir.
Arsishman,
Present, sir.
Rehan,
Present, sir.
Partha, Partha, absent. Rishikesh,
Present, sir.
Hermiki,
Present, sir.
Nohasol, Nohasol, absent. Theza,
Present, sir.
Rishikesh not, absent. And Emil, absent. Okay, so thank you everyone. Meet in the next class.
Thank you, sir.
Thank you, sir.